In this video, we will explain the behavior of mixed cell references. The cell's reference comprises a column reference and a row reference. In a mixed reference, one of them is fixed while the other is relative. Mixed cell references are of two types, column fixing and row fixing. Let me first explain column fixing. In column fixing, column reference is fixed, whereas the row reference remains relative. The cell reference $E1 is an example of column fixing. Next, the row fixing. In row fixing, the row reference is fixed, whereas the column reference remains relative. The cell reference $1 is an example of row fixing. Now, I'm going to show you how these two types of referencing behave when the formula containing them is copied both across a row and down a column at the same time. Let me begin with column fixing. Consider the formula equals $A1 in cell E5. I'm going to copy the formula to cells F5 and G5. In this case, the row reference won't change as we are copying across the same row, and the column reference won't change because column references are fixed. In this sense, the cell reference $A1 behaves just like $A$1 when copied across the same row. On the other hand, let me copy the formula to cells E6 and E7. In this case, the column reference will not change as we are copying down the same column. The row reference change because row reference is a relative reference. In this sense, both $A1 and A1 behave in the same manner when the formula containing them is copied down the column. Now, the question is, when should we use references with either column fixing or row fixing? There are situations when we want column references to remain the same when copied across a row, and row references to remain the same when copied down in a column. Let me illustrate this with an example. First, the cell references with column fixing. Let us enter the formula equals $A1 in cell E2. And let me copy this formula down to the cell range E4 and across to column H. You can see that all copied formulas in columns E, F, G, and H have the same column reference, whereas the row references are different in row 3 formulas compared to row 4 formulas. Next, consider cell references with row fixing. Let me enter the formula equals $A$1 in cell C8. And now I'm going to copy the formula across to column E and down to row 10. You can see that the row references remain the same in each of the copied formulas. However, column references in columns D is different from that of column E. Contrast the behavior of the cell reference with that of a relative cell reference. Consider the formula equals A1 in cell D8. Let us copy the formula across to column E and down to row 10. You can see that the formula in each cell points to either a different row or a different column. A mixed cell reference, in this case, would have pointed to either the same row or the same column.
In this video, I will illustrate the application of fixed column reference. The cell range D3 to I5 gives the sales generated by salespeople, and cell range B3 to B5 has the commission rate for each salesperson. And in cell range B9 to G12, we want to compute the commission amount. There are different ways in which we can create a formula to compute the sales commission. We want to create a smart formula that we can copy to other cells to compute the commission amount. Let us try to write a smart formula in cell B9. First, let me multiply the cell B3 with D3 and copy the formula to B10. I'm expecting that in B10, the formula should compute Norbert's January commission. In cell B10, the formula is B4 times D4, and its row reference has changed from 3 to 4. It is correctly referring to Norbert's commission rate and his January sales amount. It may look like we've written the correct formula, but hold on for a while. Let me now copy the formula to C9. I'm expecting the formula to compute Robert's February commission, but it is returning 0. The commission cannot be 0 as the sales in February is not 0. There must be something wrong with the formula. Let us click F2 and check the formula. You can see that the formula is C3 times E3. It refers to the February sales amount, but does not refer to the cell B3, which has the commission rate. When we copy the formula from one cell to the other, the formula references change. Sometimes it changes to our advantage, and sometimes to our disadvantage. In this case, we do not want the column reference to change. We should have written a formula that has a fixed column reference. We should have referred to cell B3 as $B3. Let me change the formula now. We can copy the formula $B3 times D3 down to C11 and across to G11, and it should return the correct value in all cells. We can check whether the formula does the computation correctly. Let me press F2 and check the formula in E10. We expect it to compute Norbert's April commission, but we can see that the formula refers to cell B4 and G4. This means the formula is correct. Using a fixed column reference, one can create one formula to compute the commission amount for all these cells. In this video, I will illustrate the application of fixed row reference. The cell range B6 to D11 gives the commissions generated by salespeople, and cell range E2 to G2 has the bonus rate for each salesperson. And in cell range E6 to G11, we want to compute the bonus amount. There are different ways in which we can create a formula to compute the bonus. We want to create a smart formula that we can copy to other cells to compute the bonus amount. Let's try to write a smart formula in cell E6. First, let me multiply the cell E2 with B6. E2 is a bonus rate and B6 is a commission amount. Let me copy the formula to F6. I'm expecting that in F6, the formula should compute Norbert's January bonus. In cell F6, the formula is F2 times C6. The column reference has changed from E to F for commission amount and B to C for bonus rate. It is correctly referring to Norbert's January commission and his bonus rate. It may look like we have written the correct formula, but hold on for a while. Let me now copy the formula to E7. I'm expecting the formula to compute Robert's February bonus, but it is returning 0. The bonus cannot be 0 as the commission in February is not 0. There must be something wrong with the formula. Let's click F2 and check the formula. You can see that the formula is E3 times B7. It refers to the February commission amount, but does not refer to the cell E2, which has the bonus rate. When we copy the formula from one cell to the other, the formula references change. In this case, we do not want the row reference to change for bonus rate. We should have written a formula that has a fixed row reference. We should have referred to cell E2 as $E2. Let me change the formula now. We can copy the formula $2 times B6 down to E11 and across to G11, and it should return the correct value in all cells. We can check whether the formula does the computation correctly. Let me press F2 and check the formula in F8. We can expect it to compute Norbert's March bonus. We can see that the formula refers to cell F2 and C8. This means the formula is correct. Using a fixed row reference, one can create one formula to compute the commission amount for all these cells. In this video, I will illustrate the application of mixed references. In this example, we have to create a smart formula by using the appropriate referencing type. The cell range B6 to B15 gives the quantity sold for a product, and cell range C5 to G5 has the product's price per unit. And in cell range C6 to G15, we want to compute the revenue. There are different ways in which we can create a formula to compute the revenue. We want to create a smart formula that we can copy to other cells to compute the revenue. Let us try to write a smart formula in cell C6. Revenue is equal to quantity sold multiplied by selling price per unit. First, let me multiply the cell B6 with C5. B6 is the quantity sold and C5 is the price per unit. Let's now consider whether we want to let these cells remain as a relative reference or should we change them. Let me begin with the cell B6, which has the quantity sold. When we copy the formula across, the quantity sold column should remain constant. Hence, it should have fixed column reference. When we copy the formula down the column, the quantity sold rows should change. Hence, it should have a relative row reference. So B6 should be changed to $B6. Let's now focus on the price per unit. When we copy the formula across, the price per unit should change. Hence, it should have a relative column reference. When we copy the formula down, the price per unit should not change. Hence, it should have fixed row reference. So C5 should be changed to $5. So the final formula should be $B6 times $5. Let me make these changes and press enter. and I'm going to copy the formula down to C15 and across to G15. We can check whether the formula does the computation correctly. The source cells are in either the first row or the first column. Therefore, let's pick a cell that's not in the first row or first column. Let me check the formula in F9. We expected to multiply 20 and 7. Let me press F2 and we can see that the formula refers to cell B9 and F5. This means the formula is correct. This way, we can create a formula to compute the revenue amount for all these cells by using a fixed row and fixed column reference. In this video, let me introduce an application of absolute and mixed references to a real-life example. I will explain how you can use references properly to create a smart formula. In this example, we have to compute the total amount that a person will get at the term deposit's maturity. The cell range B7 to B16 gives the amount invested, and cell range B2 has the interest rate, and cell range B5 to H5 has the term or the period of that deposit. And in cell range B7 to H16, we want to compute the maturity amount. Here's the formula to compute the amount. It is amount equals principal multiplied by 1 plus the interest rate to the power of the number of years. There are different ways in which we can create a formula to compute the amount. We want to create a smart formula that we can copy to other cells to compute the amount. Let's try to write a smart formula in cell B7. I will write equals, select A7, then multiply, enter opening parentheses, then enter 1, then add, now select B2 cell, then close the parentheses, enter a caret, select B5, and finally press enter. The formula has computed the amount that you will receive at the end of 1 year. Let's now think whether we should let these cells remain as a relative reference or should we change the reference. First, let's focus on the interest rate, that is B2. When we copy the formula across the row, the interest rate column should remain constant. Hence, it should have a fixed column rate. When we copy the formula down the column, the interest rate row should remain constant. Hence, it should have a fixed row reference. So B2 has both row and column fixed reference. It means B2 has absolute reference. So B2 should be changed to $B, $2. Let me do it. Next, let's focus on cell A7, which has the principal value. When we copy the formula across the row, the principal column should remain constant. Hence, it should have fixed column reference. When we copy the formula down the column, the principal row should change. Hence, it should have the relative row reference. So A7 should be changed to $A7. Let me do that. Let's now focus on the years, cell B5. When we copy the formula across the row, the years should change. Hence, it should have a relative column reference. On the other hand, when we copy the formula down the column, the year should not change. Hence, it should have a fixed row reference. So B5 should be changed to $5. Let me change that. So the final formula should be this. Let me press enter. We can copy the formula down to B16 and across to H16. Now, let me copy the formula down to B16. Let's copy the formula across to other columns. I will copy the formula to H16. We can verify the formula result. Now to pick a cell that is not in the first row or first column. Let me check the formula in F11. We expect it to refer to A11, B2, and F5. Let me press F2. We can see that the formula refers to cell A11, B2, and F5. This means the formula is correct. One can create one formula to compute the maturity amount of all these cells by making intelligent use of different referencing types. We often have to compute the running total while solving business problems. In this video, we will illustrate how to create a smart formula to compute running total. The cell range B3 to B10 has the months, and cell range C3 to C10 has the monthly sales. And in cell range D3 to D10, we want to compute the cumulative sales. Let me begin by writing a simple formula. For the first month, the cumulative sales is that month's sales. In the cell D3, enter the formula equals and select C3. The cumulative sales in September will be equal to the cumulative sales in August added to the September sales. In cell D4, the formula should be D3 plus C4. Now copy the formula down to D10. The running total in the cell D10 should be the sum of all values. We can quickly verify the formula results. I will select cell C3 to C10 and show you the sum value in the status bar. The sum value in the status bar is the same as the running total in cell D10. This means the formula has correctly computed the running total in cell D10. However, we cannot call this formula a smart formula because it requires writing the formula 2 times. We want to create one formula in cell E3 that we can copy to all other cells in computing the running total. In cell E3, let's consider the formula and enter equals sum C3 to C3 and press enter. This formula will compute the sales of August. Let me now copy the formula to E4. Let's click F2 and check the formula. The formula is sum C4 to C4. I expect the formula to add September sales to August sales, but this formula computes the sales of September. Had the formula been written as sum C3 to C4, it would have added September sales to August. How could we have achieved this? Try to understand this way. When we copy the formula to cell E4, we want the first argument of the sum function to remain C3, but the second argument should change to C4. That is, we do not want the row reference to change. We should have written a formula that has a fixed row reference. We should have referred to C3 as $3. Let me change the formula now. We can copy the formula down to E10, and it should return the correct value in all cells. We can verify whether the formula does the computation correctly. Let me press F2 and check the formula in E10. We can see that the formula refers to cell C3 to C10. This means the formula is correct. You will notice the error icons. Excel thinks that the formula is not correct, but since our formula is correct, ignore the errors. I will select all cells with errors and click on the warning icon and select Ignore Error. One can create one formula to compute the cumulative sales amount for all these cells using a fixed row reference.